All right, let's jump right in. Today, we're tackling one of the biggest ideas in AI right now, Retrieval-Augmented Generation, or as everyone calls it, RAG. Now, you've probably heard the term, but we're going way beyond the basics to see how these systems are being engineered to be smarter, faster, and a whole lot more reliable. This quote from Melee Search, it just nails the whole point of RAG. At its core, it's all about stopping these powerful language models from just making stuff up. You know, those hallucinations we hear about. The idea is to connect them to a real, factual knowledge source, like a company's private docs or a Celid database. So that sounds like a perfect fix, doesn't it? Just plug the AI into your data, and boom, you get perfectly factual answers. But, and this is the big question for today, what happens when that simple connection isn't good enough? What if the information the AI grabs is just plain wrong, or maybe it's missing the point entirely? To really appreciate why these advanced solutions are so cool, we first have to get our heads around the problem they're trying to solve. So let's start with the most basic version of this, what people in the field call naive RAG, and see exactly where it starts to fall apart.
Okay, so the naive workflow is, well, it's beautifully simple. You can see it right here. It's basically a straight pipe. A user asks a question, the system does a quick search for documents that seem to match, it bundles it all up, and then shoots it over to the language model to spit out a response. It's clean, direct, and for really simple questions, it's actually pretty fast.
But that simple pipe, it's got some serious leaks. It can easily pull up the wrong document just because of one tricky keyword. It can get totally mixed up by ideas that sound similar but are actually very different. And maybe the biggest flaw of all, it has no way to check its own work. It can't verify if what it found is any good. So if that first search is garbage, guess what? The final answer is guaranteed to be garbage too. We obviously need something smarter. And that brings us to the really cool part, the first set of powerful solutions. This is where we leave naive behind and start looking at a whole toolkit of advanced methods, all designed to fix those exact problems with accuracy and getting the nuance right. And this slide just illustrates that first big leap perfectly. Over on the left, you've got naive RAG, retrieve, generate. Simple. But look at the right, corrective RAG, or CRAG. It sticks these two crucial steps right in the middle. Evaluate the relevance, and then correct or refine the search. It doesn't just blindly trust what it finds first. So here's how that works. If the system pulls up a document that's kind of weak or maybe totally off topic, corrective RAG's evaluator catches it. And instead of just passing that bad info down the line, it stops, throws out the junk, and can kick off a brand new, smarter search to get better info. It really is like having a diligent fact checker on the team who refuses to cite a bad source. Self-RAG takes this whole idea of self-awareness to a totally different level. It actually uses these special little things called reflection tokens to constantly question itself. Before it even does a search, it asks, wait, do I even need to look something up for this question? And then after it writes an answer, it asks, hold on, is what I just wrote actually backed up by the facts I found? It's literally correcting its own mistakes before you ever see them. Now for a completely different angle. While those other methods are about verifying facts, Graph RAG is all about understanding relationships. Instead of just grabbing isolated paragraphs of text, it uses what's called a knowledge graph to actually see how different ideas and data points connect to each other. This is huge for helping the AI understand nuance and context, especially for those really complex questions. Okay, so we've made our RAG system way smarter and more accurate. That's awesome. But all those extra checks and complex thinking, well, that takes time. And that initial search itself can be a huge performance bottleneck, especially when you're dealing with massive databases. So what about speed? How do we make RAG faster? Just look at this number, 77.2%. That's not a typo. Researchers found that a really clever technique called approximate caching can cut down the number of expensive searches a system has to do by almost 80%. I mean, that is a massive, massive boost to speed. And the idea behind it is just brilliantly simple. You know, imagine one person asks, what's the company policy on refunds? And a minute later, someone else asks, hey, how do I get my money back? The words are different, but the meaning, the intent, is pretty much identical. Approximate caching is smart enough to see that, and instead of doing a whole new expensive search, it just says, hey, I've got this, and reuses the documents it found the first time. So we've looked at all these advanced tools for accuracy, for understanding deep connections, and for pure speed. This brings us to the big practical question. Which one do you actually choose? And the key takeaway here, really, is that there is no single best answer. It is all about trade-offs. This table lays it out perfectly. You want maximum accuracy and reliability? Corrective RAG is your friend, but it's going to cost you in speed and money. You need to understand really complex relationships? Graph RAG is incredible, but get ready for a lot of work up front. And if speed is absolutely everything, caching is a game changer, but it's not going to help you much with totally brand new questions. And that leaves us with this final, really critical thought. This whole world of advanced RAG, it isn't a race to find one single winner. It's a toolkit filled with specialized instruments for different jobs. So the real skill isn't asking what's the best RAG. It's asking what kind of RAG does my specific problem actually need? And figuring out the answer to that question is what separates a pretty good AI application from a truly great one.